Here's a quick explanation of each of the answers to the last unit test. I will be going through these explanations very quickly, so pause the video, replay it if you need to, and especially be sure to read the question and try each question out before you listen to my explanations. So the very first question, we're looking for the one that is sufficient to prove that it's a rectangle. Notice that on the side of the paper I've already labeled a parallelogram ABCD and a rectangle ABCD as well, and drew in the diagonals. The answer would be choice 3, because the other choices are true for both the rectangle and the parallelogram, such as the very first one, that these alternate interior angles are equal, and that's true for both a rectangle and a parallelogram. So knowing that those angles are equal is not enough to make it a rectangle. In choice 3, the diagonals of this parallelogram are equal, and as you can see, it is shaped like a rectangle. For this particular picture here of just a generic parallelogram, the diagonals are not the same length, therefore it is not a rectangle. For question number 2, it says which of the following produces something that is not congruent? That would have to include a dilation. So we're down to choices 2 and 3. And looking at those two choices there, choice 3 would reduce each length by 1/2, but then increase each one by twice as much afterwards. So that would be shrinking something down and then reducing it to its original size. In choice 2, we are shifting or sliding the shape, and then we're making each side 3 times as big, and that would be the one that would be changing the size of the shape. For question number 3, rotating or revolving a shape continuously over a line would create a 3-dimensional shape. So you have to picture this quarter circle being spun around and around and around and around and around, creating a half a sphere or a hemisphere. If they did ever ask you to find the volume of this, remember there's not a volume formula for a hemisphere given to you on the formula sheet. You'd have to take the full sphere formula and divide it by 2. For question number 4, that question takes a little patience to figure out. It says that these are perpendicular to each other. So one thing that you can do is make up some numbers here, since there aren't any numbers here. And this might be the quickest way to convince yourself what the answer might be, is produce 2 numbers there, make them different, that'll add up to 90 degrees, and find out which choice actually does work. And it would be choice number 2. If you plug both of those into the calculator, you'd find out that the cosine of DEF is identical to the sine of FEG. When 2 angles add up to make 90 degrees, when they are complementary, the sine of one will equal the cosine of the other. For question number 5, you have to know your shapes. It's a decagon. A decagon has 10 sides. I mean, there's other popular shapes too, of course. Triangle with 3 sides. A quadrilateral has 4 sides. Pentagons with 5 sides. Hexagons 6. Octagon 8. Nonagon 9. Decagon 10. Dodecagon 12. Those are the most popular ones that can show up on the exam. And they want to know what is the minimum number of degrees that would map a decagon onto itself. And if you remember back through the year when we talked about polygons like this, if you draw in the spokes to it, like a spokes to the wheel, you can consider that there are 10 divisions of this shape, and it would take a twist or a rotation from one of those sections to make the shape snap onto itself once again. So you're talking about doing a rotation of this many degrees to bring, let's say, point A onto point B again. So it's 360 degrees all the way around inside a circle, and we're going to be just dividing that by 10 to get 36 degrees. And question number 6. They're showing a dilation of 3. So each side is getting 3 times longer. We're looking for the statement that's true. And right off the bat, we can cross out choice 3. The angles aren't getting bigger. The size is getting bigger, but the shape is staying the same. Could this be a possibility, the distance from A to C prime? I mean, if you travel from A to C prime, is that the same as traveling from C to B prime? It's not even close. So it can't be choice number 1. With choice number 2, is AB divided by this equal to 3? No, it's actually equal to 1/3. It's a third of the size, not 3 times as big. But it is choice number 4. The distance from the center of the dilation to the image is 3 times as big as the distance from the center to the original. For question number 7, we're looking for the one that would take the pre-image, bring it to this image, and then bring it to this image here. And that's a reflection followed by a translation. So it's a flip followed by a slide. For question 8, you're going to use a technique called completing the square. And to accomplish that, I'm going to show you the technique that I use called split and square, and remind you about how that goes. So the very first thing I'm going to do is organize this by putting the y's near each other, the x's near each other, and if it doesn't have an x or a y, I'm going to bring it to the other side of the equation. So I'm going to subtract 3 from both sides and just lay it out that way. So the technique that I use here is called split and square. And with this technique, I'm going to get an organized equation of a circle very quickly. So as I said before, I'm putting the x's all in the same neighborhood, the y's all in the same neighborhood, and my goal is to turn it into an equation of a circle that looks like that. So the target is to have an equation centered at another point and other than the origin, and the technique is called split and square. So to find an alternative equation that actually means the same thing as the one in white above, we're going to split the numbers that we see and then square the number. So -2 split in half is -1, and -1 squared is -1 times -1, which is +1. If I add it to the left side of the equation, I also have to add it to the right side of the equation to keep the equation balanced. I do the same thing with the 6. The 6 split in half is a 3, and 3 squared is 9. So I'm going to have to add 9 to this side of the equation and also add 9 to the other side as well. So on the right hand side of the equation I get 9, 10, I get 7. And now I've got the equation organized where I can just read what the center is and the radius is. So just remember on these questions, when you're trying to read the center, you're not just going to take those numbers, you're going to take the opposite of each of those numbers to create the center point. So the center won't be -1, +3. The center will be +1. And since that's a +3, that would change into a -3. And then the radius is not 7. The radius would be the square root of 7. So in this question here, I'm looking at choice number 1 is the answer. For question number 9, we're looking for something that's perpendicular to this equation here. And once again, if you didn't read the question yet, read it. Try the question first before you watch the explanation. So here's the explanation of it all. If you're trying to figure out this equation's slope, the very first thing you want to do is to get the y by itself. And I'm going to subtract x from both sides, giving me -x plus 15 on the right hand side. Dividing by 3 quickly gets me that the equation can be rewritten as -x over 3 plus 5. So taking a look at what we've got, so the slope of what we've got right now is -1/3. If I want something that's perpendicular to it, the slope that I need won't be -1/3, but it'll be the negative reciprocal of that. So the negative reciprocal means to change the fraction completely around. Instead of being negative, it's going to be positive. Instead of being 1/3, it's going to be 3/1. So the equation that I need will have a slope of 3, so it has to be either choice 1 or 2, and that's where this point comes in, is to help me figure out which of the two it's going to be. One way to finish this question off is to plug those numbers in for x and y into each of the choices. So if we tried out choice number 1, which is a candidate for a possible answer, if I plugged in the -6, I get -18 plus 19, which equals 1. So you can see that that y value came true. The y came out to be 1 when I used a -6 for the x. So this is the only equation that could work out, choice number 1. Question 10 could be done 2 different ways. Maybe the easiest way is to know that this would be a right angle, since this is a tangent line drawn to the circle. So the radius is making a 90-degree angle there, leaving this angle here to be 36 degrees, because in a triangle all 3 angles have to add up to 180 degrees. And if it's 36 degrees as the inscribed angle, it's 72 on the arc, twice as much. And here's another way to work the question out too. So let me backtrack. So if you didn't know that fact about the right angle, you could still get the answer another way. This would be 180 degrees for this semicircle, and we're looking for this arc here. And there's a rule when it comes to the exterior angle, that the exterior angle is equal to half of the arcs subtracted from each other, the arcs that make up the result when that angle cuts through the circle in those places. So in this particular case, we're looking for the smaller of the 2 arcs, and you just have to plug in the information from the picture. The larger arc is 180 degrees, the smaller arc we don't know, but we know that the exterior angle is 54. And you could solve this equation a few different ways, or just take these numbers and plug them in and find out that 72 is the right answer. As we'll show really quickly. I mean, a very quick way to solve this question is to multiply both sides of the equation by 2. So that gives you 108 is equal to 180 take away x. And then you can finish solving the question by subtracting 180 from both sides, giving you negative 72 equals negative x. So divide by negative 1 and you get x is 72 degrees. Okay, on to question number 11. That's going to involve possibly some trigonometry, possibly some Pythagorean theorem. And the way that I know that is because I see some right triangles in the picture. Now it could also involve similar triangles too. So I'm not saying that's going to be SOHCAHTOA, I'm just saying it could be a possibility. Okay, looking at this question and labeling it. So with the labeling in, I've got all that information from the picture, or on the picture. The only thing I still need is put an x in place. We're looking for the length of ED. So that would be x. And by the looks of this, to figure out that length right there, I guess I could use trigonometry, but a much faster way to work the question out is just to play a matching game with what matches up with what in each picture. So the x matches up with the 1.5, and the x came from the big triangle. Now I need another side from the big triangle. So in the big triangle, we know that's 12 all the way across from there to there. So the 12 matches up with the 2 in the smaller triangle. Once you cross multiply, you end up getting the answer that x is equal to 9. And another way to get the question right is to find the scale factor between the two triangles. And the formula for scale factor is the image over the pre-image. And if the image is the larger triangle, the scale factor is 12 over 2, or the scale factor is 6. So the larger triangle is 6 times bigger than the smaller, so 6 times 1.5 would also get you the answer. Also notice you can get close to the answer by just looking at the choices. It's probably not choice 3 and choice 4 right off the bat. For a question like number 12, I'm trying to find out through this question if you understand which of the words go along with what type of reaction you get from the transformation. And this one is a push or a slide. Everything is sliding to the right from image 1 to image 2. And those yellow lines are all examples of vectors, and they are the same length as the vector from F to G. So this would be a translation or a push or a slide from left to right, and not any of the other ones. There's no spinning going on, it's not changing size, and it's not flipping. If it was flipping, E would end up far across on the other side, over here someplace. Moving ahead to question 13 and trying to track down the right answer. This is all about playing a matching game and find out which one is not showing good matching. And with some patience there and figuring it out, it's choice 3 as being the one that is false. Because if you matched AE up with AD, that would be okay, as long as maybe you finished with EF over DG. But in this question, in this choice right here, it's not what they did. They went EC, which is all of this, matching up with AC, which is the whole thing. And that's not showing good matching, so this would be the one that is false. The other ones actually all agree and actually work out. Question 14. We're going to need a volume formula for a prism or a rectangular box. and volume is big B times H, or length times width times height. So very quickly, if you multiply 5 times 3 times 4, you get 60. So the volume of the tank is 60 cubic feet. They're telling you that water is very heavy, that water weighs 62.5 pounds per cubic foot. So multiplying by that number will tell you the weight of the tank if it was filled completely. So it would weigh 3,750 pounds if it was completely filled with water, but we're only filling it 90% of the way. So 90% of 3,750 would be calculated by multiplying those together, or even just taking a look at the choices. So if we're taking 90% of 3,750, it's going to be a little bit below 3,750. It wouldn't be that drastically low, it wouldn't be heavier, and it wouldn't be just nearly the same. For question number 15, that is showing off something that's called Cavalier's principle. I believe that's spelled right. Cavalier's principle says that if there are several cross sections that are all scattered about, that would be exactly the same as the volume as if they were organized and straightened out. So the pile of CDs will end up being the same as the volume of a cylinder once they are placed correctly, once they're stacked up correctly from that picture. So in this question right here, we just need to find the volume of a cylinder. So using our formula sheet, you can find the volume of the cylinder is pi r squared times h, which will bring you to pi times, well, the diameter of each cylinder, of each CD is 120, so the radius would have to be 60, and the height of each disc is 1.2. So that would be the volume for one CD. You could figure out that and then multiply that answer by 50, because there are 50 CDs stacked up. So once you type that into the calculator, you get approximately that. So that would be the volume in millimeters cubed. Question 16, that's an important one to make sure you don't get stung by this. It is true that one triangle has each of its sides reduced by 10, but that is not a dilation. A dilation would be as if it got, let's say, each side divided by 10, and that was 3.6 and 3.8 and 6.0. That would be an example of a dilation. This is not a dilation, and it was really good to see that some students actually remembered that you can try to compare the scale factors. And if you divide the matching sides together, you do not get the same answer through all three pairs of sides. So this is not a scale, 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 or side, side, side similarity. So it's not a dilation. So that means that they are not similar. They have a different shape to them. For question 17, I also tried to catch you on this one as well. It says determine if the triangles above are congruent. And wouldn't you know that New York State did something very similar to this a couple years after I made this question up. It's almost like they were spying on me. So for this particular case, it looks like it's a translation. It looks like it's a slide 7 spaces to the right and 1 down. So that checks out okay for point B. If I go 7 spaces and 1 down, it brings me to point F. But if I did the same move here and go 7 spaces and 1 down, it should place me right here at 4, 0. So this is not a translation. It's not perfect. So we know that the triangles would not fall in line on top of each other or onto each other. So they would not be congruent. Now, I would love to see a little bit more work, and that could just be simply figuring out how far it is from A to C. So that's 1 space up and 5 spaces across. So to figure out the length of AC, the slope of AC is up 1 over 5. The length would be the square root of 1 squared plus 5 squared, which would be radical 26. You could do the same exact thing for DF and show me that it's not the same length. That would be, for DC, the slope, or DF it was. For DF, the slope would be up 1 over 6, and then the length would be the square root of 1 squared plus 6 squared, which is radical 37. Now the other lengths check out. The other lengths are congruent. But to be congruent, all 3 sides on one triangle have to have a matching side or an equal side to another triangle. And that is the end of the first part of the practice test. And there'll be another video that goes over the second part.